Let me turn the music. I'm going to jam here. I'll turn the music up a little here.
Banjo of science.
Oh, yeah.
Yeah.
More banjo.
Less banjo.
My favorite part. Listen how it just hangs here out in space. I'm going to drown out the Morocco players.
Oh, you don't want to do that.
Wow, was that fun or was that
You are
fun?
right. That banjo is hanging out there in space, gagging for air.
Now, hey. We don't criticize banjos here.
You always criticize banjos. It's part of the fun. I
Wow.
just want to say, and you guys out there can keep this a secret. I love banjo,
I do love banjo.
but it's part of the American tradition
It is.
to just give them a hard time
Well, banjo. I was.
because that makes them play harder.
Oh yeah, or make
And
some
louder.
noise. Well, I'm just going to
And
say.
more.
I'm just going to say I returned from the Cliff Top, the old time music festival in Camp Washington Carver, which is a wonderful place. And Cliff Top, this festival has been going on for years. It was kind of, last several years they couldn't have it because of the COVID problems, but they've reinstituted, and people come from all over the United States and around the world. I mean, there literally are like old time music bands that come from Europe and Germany and the Netherlands. Oh, it's just really a wonderful thing. So, of course, but it's not just because I play my final banjo here that I brought it. It's because this is a
beautiful
demonstration project. Now, I know that if I hold this up to the microphone, people will see I have my my nice old Gibson banjo, and it's kind of weathered, as you can see. People aren't looking at this.
Used, I should say.
But there's something very special about this
There
banjo.
is something very special about that. In fact, I am on the insider track to know exactly what that is.
I'm looking. I see this.
That is possibly the first product made with nanotechnology.
Well, in this is
That we
literally
know of.
This is November 1999. That what I have on my banjo. People are going, well, what do you have on your banjo besides a lot of apparent residual dirt and miles and miles before I sleep and all kinds. The thing that makes this banjo a little more interesting than the fact that it's a 1956 Gibson banjo. I have it sort of tuned to a mountain modals. This is
Modal.
This tuning, which is they call it some people call it mountain minor or
Okay.
a modal. But there's something interesting about this tuning, and only a few people will get this. I'll play this series of notes, and then anybody that gets it can laugh or chuckle to themselves.
Okay. Dun, 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 dun,
I'll do it one more time, and then you. That's actually the tuning. Now that. So for Scully and Mulder, this may make some sense.
So are you
West
telling
Virginia,
me
mountain minor.
that Close Encounters of the Third Kind, the music that they play to the aliens back and forth is literally coming from Appalachia?
What? I hadn't heard about that. No, seriously, I don't know what to say about it. But, there's a kind of a synchronicity thing that goes on in music and space and alien technology. And
is it that aliens are from Appalachia?
I don't.
Or Appalachians are aliens?
I'm just saying that's the actual tuning for this classic banjo tuning.
I want to start sculpting mashed potatoes.
All right, so that's the first part that's interesting about this. There's always a lot of interesting math and connection between science and music. But I just found it really amazing that particular series of notes is the tuning for classic banjo stuff.
That's really interesting. So literally, when the Earthlings were talking to the aliens, the aliens were essentially going, "Hey, play Foggy Mountain."
I see. I'm not going to take it that far. I think maybe you're
Dueling banjos with the aliens.
I think that you're.
I like that.
I think you're either interpolating or extrapolating or one of those two. But I'm just saying these notes are so cool.
I could be just imploding.
You could be doing that too. Now, the reason why I brought this banjo was because I have on this banjo that I put on it in November 1999. It's still in perfect shape.
It is indeed.
I was just talking to somebody at a high-tech carbon nano. I actually talked to a fellow, Elliot Kennel, and it turns out, besides the fact that he started off as a physicist, then he went into coal research, and he was involved in a whole bunch of coal to carbon things that happened back in the 1989.
Oh yeah, way
90s.
back when.
And the reason why I put this on my banjo back then, it was because John Zondlo and Al Stiller, two great researchers, and other folks down there.
Fabulous researchers at West Virginia University.
Well, Elliot Kennel was involved in it too, but the thing that they did was got a grant to make nuclear grade graphite. Because the nuclear industry said, well, you can't make the pure fabulous graphite we need from coal, for heaven's sakes.
And they said, watch this.
Yeah, and they did. So besides coming up with a nuclear grade graphite that was made from coal instead of petroleum products, which was a big deal, they found out that in the process they could derive materials that allowed them to make the first big thing they made was carbon foam. The second thing they started making was all sorts of carbon fibers from mesoform pitch.
So when did they start making the first carbon fibers from coal and the first carbon foam from coal? Was that like the 1980s, the late 1980s?
Yeah, late like 1989 into the early 90s. Anyway, but the thing is, this actually is it's made of carbon foam, and then on the top, I was talking to the guy at first. He said, it looks like you have a little bit of carved ebony because it's a compensated bridge on the top. And at first I was thinking, I think I cut the ebony, but then I realized that it actually is ebony, but it's an ebony composite, because I had some ebony at home, and to cut something brittle like ebony into this kind of cool curve is a tough thing to do, and then you have to shape it. I actually sanded till I had a huge, not a huge amount, but a little spoonful of ebony, like very fine things. Then I mixed it with epoxy, so it's actually an epoxy ebony composite. So this whole thing is like,
wow.
I mean, it's like swoopy. Anyway, but I digress.
It is indeed swoopy.
I think we probably need to start the show.
Hey, sure.
Let's get rolling.
Let's do that. Hey, if you're tuning in, you're listening to Radio Science News. This is episode number 851 in a series.
Wow.
I know. And they still are, they are either unaware of us or they are trying to ignore us. I'm not sure.
I'll tell you about my terrible dream later, but let's go ahead.
Okay, good. August 13th, 2022. If you're a prime number fan out there, the factors of 851, it's not itself a prime number. But the two factors are 23 and 70.
Ooh, so close. So close.
Excuse me. I dyslexified that. 23 and 37.
Close.
Not 73. Okay. So if you would like to join Richard and I, my name is Robert Strong, and Richard Pollock to my right, your left out there. If you go online to www.smartcenter.org, SMARTCENTER.org, that brings you to the fabulous webpage for the Smart Center.
I saw your picture. That's not what makes it fabulous.
No. That's not what makes it fabulous. That's what brings it down from oh my gosh down to fabulous.
I see.
So if you find the trifecta rainbows that in triplicate say Radio Science News, just above that is the live link to Radio Science News, to the launch pad of science, which Richard lovingly puts up every single week for your science and convenience. As you're pulling off to the side of the road, if you do not have one of those drive-it-yourself cars, so that you can join us here, you will notice that there is a plethora, and when I say plethora, I'm using the dictionary definition.
Wow.
There are a lot of live links here, and these are all links that Richard has checked to make sure that they are kid-friendly and therefore adult-friendly. So we've got Tesla Semi.
Tesla Semi, good big news from Tesla, I'm telling you.
The EV tax.
EV tax credits.
EV tax credits. Okay. And then the Armory.
Well, this is a guy that
Lovins.
this is a guy that's been around. We're going to touch bases with
not sure I know
Amory Lovins of the Rocky
that's,
Mountain
Amory?
Institute.
Oh, okay. I misread that this morning. Okay.
I have something from him
And
in
then
2002.
2022.
Can we do a retrospective? I go back to something that he was talking about 10 years ago. As
and
if it
now you bring it up to date. Ooh, very swoopy. Nanocellulose.
Nanocellulose.
You know, I would consider cellulose at its base level is probably all nano, isn't it?
Well,
That's really interesting.
Once you get down to, but the thing that's real interesting, I just kind of threw this in context with some of these other things we're going to talk about here.
Then GM, I assume that's General Motors.
Oh yeah, there's the car. I have the car
2023.
that you may want to order, but
Okay.
maybe not. I don't know.
There are cars that I want to order. The only problem is available cash.
Well,
But surely, when my check from Radio Science News comes in, if it ever comes in,
yeah, you'll get that retirement the watch. You'll get a digital watch.
And
too.
then meteors.
Meteors.
Because there's a meteor shower actually going on as we speak. Isn't it?
That's going on, but this is something that happened so long ago and is now being posited as part of an interesting theory. You're going to like this.
Okay, I love interesting theories. Magnecular.
This one
so
is.
we are going to revisit for the umpteenth time.
Well,
magnecular.
We're going to touch.
If you haven't heard that phrase before, folks, hang in there because this is really cool.
Well, it is, and this was something that comes almost tangentially from another article about something.
Oh, that's neat.
And when I read the article, I thought to myself, oh, this is interesting, and they think it's a little mysterious, and I'm going, I think I might know what's happening. So
imagine that.
And then I'm going to talk about finally get to the dice that we were talking about.
Dice.
And then some folks just up the road from us in Pennsylvania have come up with a real cool concept for incorporating graphene into carbon fiber stuff.
Oh,
and we'll just touch on that. Then the stories I didn't get to last week, eDNA and Nanobot.
Okay.
I dumped the one the back two. I moved them down. If we have enough time, we'll go down to them.
That sounds like a plan.
Let's jump right in and take a look. This is just a quick thing from the Tesla folks. Now,
Tesla Semi.
as you know, they do a lot of things, and
they do a lot of things.
sometimes they do them in a semi way, but in this. This is about. I wonder when you see this picture of it. So look at this little thing down here.
Elon Musk says Tesla semi-electric truck deliveries will begin this year, after 3 years of delays and broken promises. Boy, that's a mean thing to say.
I know.
Tesla claims its semi-electric truck will finally be delivered to U.S. customers from later this year. You know, I must say I like the looks of it, the lines of it. It's very nice.
Three images. Well, and the thing is, the looks of it are pretty much. It's not just because they wanted it to look really cool. It's that it's absolutely functional in terms of aerodynamics and all that. You can see.
Right. So it says Tesla requiring customers to place a US $20,000 or Australian $28,300 deposit to secure a place in the queue. Tesla's first commercial vehicle has a claimed driving range of 500 miles. That's 805 kilometers when empty in its top-of-the-range variant, which is priced from $180,000 American, $255,000 Aussie dollars, plus on-road costs. Now, what are the on-road costs?
I don't know.
I would assume that's
maybe
being charged.
I'm not sure.
But the less expensive variant, $150,000 US, plus on-road cost with a shortened claimed driving range of 300 miles. Powered by 4 electric motors which drive the rear wheels. Tesla claims the semi can accelerate from 0 to 100 kilometers per hour, which is essentially 60 miles an hour.
It's like a drag
in
strip.
5 seconds when it is unladen.
0 to 60, that's one of those big deals, yeah.
With a full payload of 36,287 kilograms. Boy, what a weird number. The Tesla Semi can allegedly achieve a 0 to 100 kilometers per hour time in 20 seconds while reaching 60 miles per hour or 97 kilometers per hour up a 5%.
Yeah, I think they changed
grade.
because this is an Australian article. They've
Really
changed everything to
interesting.
kilometers a lot of places,
that's-
as they
that's
should.
fine.
Anyway, long story short, this is really a pretty remarkable thing. And then, actually, Robert, breaking news. That's my banjo breaking news sound. I actually saw something just as I was coming in this morning that Tesla stockholders,
Yeah.
and I know you've got a big pile, I'm sure. Big pile.
I have dozens and dozens
Dozens of possible
percents share.
Okay.
Yes.
Well, I'm just going to say the story this morning was that Tesla is going to not only like give people that have I forget, they're going to give a free stock share for owner, but the big deal is they're going to split like 4 for 1 or 3 for 1.
Wow. If only I had stock.
And so I thought that would be good news for you. Anyway, I just wanted to put that story in because one of the things that this thing looks really cool, but you know what it doesn't mention that it is, Robert?
What?
Did you see anywhere in here?
Aerodynamic?
Well, no, they said it was aerodynamic, but
Okay.
you're looking at this and it looks like this looks like a molded composite body.
It could have been carbon fiber.
Well,
it
and
could have easily been carbon fiber.
I'm going to say that if it were, it would probably have said so, right?
I would hope so.
Now, don't you think that all of these things that they set up here about its achieving acceleration, 0 to 60,
and you're going.
What
the
would happen
only,
if it
the
were
only
carbon
way
fiber?
it could do that is that it has to be fairly light, and if you had it carbon fiber, as we've been talking about, it would be far lighter.
So maybe I'm just going to leave it at that. That I'm going to suggest to. I know Elon is always looking for new ideas.
Always is. Yeah.
But, I mean, he's looking for them.
Well,
Whether he comes
he's
up with them.
looking for him so that he can claim them as his own.
And I would be happy if he would claim this one.
Sure,
And,
go right ahead, Elon. Hey,
and then send Robert some more of your stock.
Yeah, right. Hey, what I find odd, Mr. Elon, is that there's this phrase, however the Tesla Semi's width might prevent it from being legal on Australian roads.
They have narrow roads.
It says
I didn't know
Australia
that.
only allows trucks which are up to 2.5 meters wide, while Tesla has said the Semi is between 30 and 50 millimeters wider than this limit. What? Why would you
What
make...
a controversy. What a controversy.
Why didn't you make it 2 inches less wide?
Well.
You just took an entire continent and said, nah, you don't get to use this. What are you thinking?
That seems rude.
Oh, come on.
All right, I think they can address that. Anyway,
I certainly hope so.
The point I would like to make, and I think that you would agree with me, is that it would be really great if perhaps all vehicles could be. I mean, the other thing about this is they may be thinking about it, but it's a cost issue.
Yeah.
And so, anyway, I'm just going to say, as an advocate for carbon composites, like I have on my banjo, I think that they should be considering.
I think, hey, Elon, I would like to give you another idea that you can claim ownership for. If you would wrap this thing in solar panels, it would go further.
Well, now it's just.
And while it's sitting around waiting for the next load, it would trickle charge its batteries.
Well, there is that.
Just,
don't overload him.
Saying, yeah,
Not
that
too many
might be
things at one
too
time.
much.
All right,
Sorry.
so I'm just
Okay.
going to jump ahead to something that happened just literally kind of yesterday.
Yesterday.
The people say a lot of times politicians don't get anything done, or they don't help you, or don't promote what they're doing.
I
But,
think I have said that before.
well, I'm just going to say that this is really kind of big news because one of the things that will be happening with the bill that was passed yesterday and will be signed in pretty soon, the Inflation Reduction Act, that as it's called, it's got a lot of stuff that is to incentivize like green technology and green energy and stuff like that. And I'm just going to touch on this quickly because basically, here's the big headlines in bold. Looks like it could be giant, carbon composite letters here. Look, it says, buying a car and want to go electric? Inflation Reduction Act will give you the $7,500 tax credit for buying a new one.
Wow.
But the other thing they're going to do is they've added a tax credit if you're buying a used one, which they didn't have before.
That they have not had before,
Yeah.
and that has kept me from being able to use these kinds of things.
Yes.
Because I can't afford a new vehicle, but I can afford a gently, triply owned vehicle.
Well,
yes.
in the case of the electric vehicles, one of the big pluses for the the electric vehicles in general is that in terms of their maintenance and stuff like that,
Yeah.
it's and people, there's a huge market out there now for like used Tesla. It's hard to believe we're actually talking about used Tesla. There could be a big
Used
lot out
Teslas,
there.
yes.
Here's a used Tesla right now. There's a big lot, Anyway, this is really cool, and I'm just going to say this is another thing where people go, okay, this is something that is helpful.
Something to think about. So you can get a tax credit worth up to $7,500
For a new
for
one.
buying an all-new electric car, or a used version of these vehicles for the tax credit can be worth up to $4,000.
Yeah.
That's a significant amount. I mean, if you're buying a used car and somebody goes, "Hey, you can get a $4,000 tax credit for buying this type vehicle over this type vehicle," that might be enough to sway some folks. And then, folks, put an electric charging station on your garage roof.
Well, all those things are nice, as they say, ancillary things,
Ancillary,
or
yep.
Upstream, downstream. kind
And
of thing.
then your electric car does not run on coal; it runs on nuclear fusion from the closest star.
There you go.
Now that's cool.
Now, the reason why I included these next two things,
right,
and we're going
what
to
you got
we're
here?
going to touch on them kind of quickly, but I'm going to ask people to take some time and look at it. Amory Lovins, click on it, and you're going to look at this. This is going to be a little video. I think it's a YouTube thing. Amory Lovins, it says here, carbon fiber cars would cut oil dependency. I want you to check out the date for me there, Robert. You
All
said
right.
March
29th, 2012.
2012. So
That's
this is.
over 10 years ago.
And he looks very kind of young and trim here with his little dapper mustache
Oh,
and all
he's
that.
so cute.
Now, what I'm going to do is I'm going to play this
Little
because
dapper
there are a
mustache.
couple things that pop up in here that you may or may not, they won't jump out at you, but there are some interesting things that he says.
So he's talking about carbon fiber cars would cut oil dependency over 10 years ago.
Yeah, how come
Wow.
my thing is not? Hey, Amory, where are you, man?
Where'd you go, Amory?
Let me try
I've
one
got
more.
here. Okay, so
try one
maybe
more
you're
time.
just supposed to play the.
I clicked it, and we're not getting anything. So
let me try.
see if
mine,
yours is
see if
working.
mine's
I listened to this whole thing, and it had some cool stuff in it. Is yours working?
Yeah, let me.
Isn't that weird? Very strange. Yeah, mine looks like it should be, but it's not.
All right, I'm got my sound off. Okay, right there.
Is yours working? Well, it could be that on our network it's not. Well, I'll tell you what. Let's just skip this. We'll let folks check this out later at their own leisure.
All right.
There's a couple things that are really cool about
That's
it.
the fun about. All right.
Oh, you're getting a Siemens ad.
I'm getting a Siemens ad,
Those are wonderful guys there at Siemens. But
and it's the Siemens ad over and over again. So something
is amiss. here.
is amiss, and that's part of doing live radio. That not everything goes as planned, and that's okay.
I'm just surprised that
I get
I'm
that.
going to let this. Now, the reason why Amory Lovins is so important is he's kind of known as like a real, they call him the Einstein of efficiency and stuff. He's figured out all kinds of things that are important for saving energy. I mean, that's the big deal. So, long story short, and when you get a chance to look at this, and I may just jump to his. Yeah, this is going to be a problem. Let's jump to the second, which is 2022,
Okay.
and see if this is a little more.
2022.
Energy
let's do
efficiency
that.
guru Amory Lovins. It's the largest, cheapest, safest way to address the crisis. I mean, the thing is, this is an article that's worth reading through on all kinds of things because he's talking about climate, economics. He's talking about structures. And here, you notice he's not quite as dapper as he was then. He looks a little bit like maybe Peter, Paul, and Mary should be calling him up and saying, "Can you play guitar?" So this is a long. This is a.
You play guitar.
This
Why,
is-
sweet Nate.
This is a long, recent article. Just to give you a sense of how long he's been here, they've nicknamed him the Einstein of energy efficiency. He's an adjunct professor of civil and environmental engineering at Stanford. So he's really.
He knows his stuff.
He
though.
wrote his first paper on climate change at Oxford in 1968. And in 1976, he offered Jimmy Carter government a blueprint for how to triple energy efficiency and get off oil and coal within 40 years. Well, let me see.
Wait. So that was when?
1976. I mean, think 86,
96.
Oh, we would already be off by now.
No.
Dang.
So I guess we didn't do that.
We must not have done it.
Oh,
So
okay, all right.
I'm just saying. But there's a whole thing, and then he goes very much into what's going on with Putin.
What a fascinating character.
And part of the reason why is because his family has barely survived issues in Ukraine years ago when everybody was killed except like 12 people in the whole area. It's a wonderful read here, but what he's really talking
So
about
he
is...
says Lovin's most spectacular early success may have been his 1991 hypercar concept, an
Yeah, that's what I wanted you
all-electric
to find.
carbon fiber body vehicle that could do 300 miles to the gallon.
That's comparable. When
Yeah.
they compare.
It was dismissed at the time, but all car makers are now moving that way. Gee, it's really tough when you're only 31 years ahead of your time.
Well,
Yeah.
I think that's going to be a problem. I feel that way with my banjo bridge, really. But there's another little snippet that I just want to, up here he says, he's talking about his house. He's got this house, it's in the Rocky Mountains, and it's completely solar heated.
Of course.
He grows his own bananas, and I don't know, does he make his own Cheerios? I'm not sure.
Grows his own bananas in Colorado.
It's
That's cool.
right there, yeah.
I like it.
I think he should put that on his epitaph. That might be good. Here it says, this one little paragraph, it turns out if you make a car out of carbon fiber, you also save 2/3 of the investment in water and half the energy space and time needed to put the car together.
Right.
So he's not just
Sure.
talking, he goes, okay, don't just talk about the savings afterward. We're talking about,
But the savings during.
yeah, and so
Yeah.
it says it needs a lot fewer batteries because it's holding less weight because the carbon fiber is light. You pay for the carbon fiber by needing fewer batteries and smaller propulsion system
Exactly.
all around. Anyway, this is a really interesting article, and it goes to kind of what we're talking about. He has several things that are going on here, but having run into some folks who are putting together carbon composite cars as I was coming back from my banjo festival, I just thought it was kind of interesting. Now, the only other thing that I find interesting, we've been talking about how we mentioned last week, and I think we probably spent a lot of time talking about. I think we tossed out a couple more $1 billion ideas that will probably never benefit.
It's
from.
our
It's
it
just
is
what
our
we
goal
do.
in life.
It's
Yes.
just what we do. But the two things that we talked about within the state of West Virginia, or at least the region. Let's just talk about the region generally, because we're going to be mentioning Penn State here in a second, and they're part of this region. The point is that as these guys who are making carbon composite body cars. And if you go back to last week and click on X Mod Carbon and look at this amazing vehicle that they're doing, you'll probably be impressed.
Yeah.
The very simple thing was, as I said to the guy, every vehicle should be made out of carbon composites. And there's so much data.
If it isn't, you need to explain why.
Well, and by looking
because
into it,
there probably are some reasons for not going that
one
direction.
of the big reasons for not doing it is because it's expensive stuff. People think,
yeah.
well, sure, it's for expensive things like banjo bridges or maybe like F-18 Super Hornets,
There you
things
are,
like
yeah.
that. But the two simple points that we were trying to make last week were that in this region, if people are going to pursue extractive technologies to provide employment and hopefully do it in a clean way, two of the things they can consider are, one, that you can make all sorts of value-added carbon products from the available stuff in our area, like coal and
Right.
any other sources of carbon. And that's why I mentioned this cellulose next.
Right.
The other is that if you're going to make carbon composites, that's typically always going to be like carbon fibers or nanofibers. And you're going to use some sort of you're going to put it in, as fiberglass people know, with some sort of a plastic,
Yeah.
So like if you have a kayak or a canoe or something that's made of this kind of stuff, that, fiberglass is a whole bunch of glass fibers, and they give one part of the composite, and then the other is that you put it in with a plastic material that now you have strength and flexibility. That's the whole deal with composites. So in our area, we could be doing both of those and supplying the rest of the world and switching
Yes, we could. And
stamped steel and stamped metal things
Right.
to these composites.
Or we could throw it in a blast furnace and burn it once.
Well, let's not do that.
Your choice.
Maybe we could just burn the used cars. All right. Now the reason why I got to this next one is like a lot of people go, well, you know, you come out of a biology background, and I
Yes,
have always said, if you can find solutions that are more from nature, or more from plants, and this little article talks about the fact that. They're looking at the fact that you can have they're talking about cellulose nanocrystals, cellulose nanofibers,
Wow, this is
nanocomposites,
really neat.
nanocellulose, and then these are all the keywords for this thing.
It says here at the abstract, it says cellulose is the biosynthetic product from plants, animals, and bacteria. Cellulose is the most abundant polymer, having long linear chain-like structures composed of 1,4 length beta D
Glucopyranosyl
units.
Not to be
assembled
confused with a piranha, but
into
pyranosol. Yeah.
a hierarchical structures of microfibers with excellent strength and stiffness.
There you
So
are.
essentially what they're saying is that
This could be it, too.
This cellulose stuff is the biosynthetic product from plants, animals, and bacteria. And it is the most abundant polymer that has this hierarchical structure with excellent strength and excellent stiffness.
So it turns
And
out
you're
that
like, wow, this is what
maybe-
could be used for almost building everything.
or even carbon composite. Hey, wait,
Right.
scratch the whole rest of the show we just had. This is one of the
This
things to
is
consider.
awesome.
The other part of it is that this is just one sentence I'll read before we jump out of this interesting article. Nanocellulose is non-toxic, biodegradable, biocompatible, with no adverse effects on health and the environment. Well, now I know why they won't do it.
That's why. Okay. So you mean that if you wanted to make, I don't know, an artificial heart out of this,
Well,
it would probably work very, very, very nicely.
yeah. Cellulose is a pretty common thing, and
Yes.
when they talk about, they do go on to talk about the it's like endless usages, but there are also the sources for it. Like it's one of these things where no, you don't have to a lot of this stuff just grows and sometimes gets in your way. Like I mowed my lawn
Weeds?
twice this last week because I would get up overnight and it would be like, I thought I mowed this yesterday.
I thought I mowed right there.
So anyway.
Stop fertilizing.
Okay. So anyway, the folks who advocate for a lot of these, very interesting and important composite kind of materials
Yeah.
need to know that, if you take a piece of wood, Robert, it actually has amazing polymers. in it.
But what kind of a factory do you need to make a piece of wood?
I don't want to have you
Folks, they're called trees.
trees. All right, now just to cleanse your palate before we go
Oh,
on to
I
something
love
else,
my
we're going to
palate
take
being
one
cleansed.
last look at the car that you may or may not be ordering. I just don't know, and this is you have time because this is the 2023 Corvette Z06.
Z06 or Z06?
I would say Z06 because I think it's so hard to say Z0 real fast.
Z0. The 670 horsepower vehicle continues to make its headway aesthetically and performance-wise with composite
Now
wheels,
I know.
wing, and aero bits.
Aero bits.
What is an aero bit?
It's those,
Is that thing on the back of an aero
it's-
bit?
well, they have
I thought that was called a spoiler.
Well, I think they were talking about some other little parts
Oh, okay,
too.
all
Maybe
right. Some other aero bits. All right.
well, and this I'm just going to say, that's all great because you can tell that obviously the parts that are the wheels and they could have done the mirrors too. They might. People do aftermarket composite
Hey,
parts for all
I
this.
just want to say, if the Chevy Corvette people could make a 4-door hatchback that I could haul stuff in, I would think about it.
Robert, I think you can get this with a trailer hitch.
Oh,
I
okay,
could be
good.
wrong. So if you are, as we hope you are, actually following the links on radiosciencenews.org, you'll be looking at a really, beautiful, aesthetically. Carbon fiber wheels are available, which reduces the weight by 41 pounds. Interior
Wow.
package with carbon fiber wrapped steering wheel. They're doing all these little things.
And they all added up, don't they?
Well, they
Hey,
do.
I just got a little pop-up that says, "Get the latest news from Composite World."
Well, there you go.
Later or allow. Of course, I will allow that.
Get it later.
Yeah.
Well, and the only thing I'm going to say is this is really nice, but what with these guys that I pulled up next to the Pilot gas station, the Goshen exit, their car, which was it was basically looked like a 1968 Dodge Charger.
Yeah.
Of course, I graduated from high school, and if I were a senior, I would have loved to have that car. I just said nice Charger, and they basically explained to me, well, it is and it isn't. And I said, you mean it is or it isn't nice, or it is or isn't a Charger? And they said, well, they made it to, even though they extended and made it look a little bigger and a little wider, they actually built it on a brand new chassis of a Dodge, I think it was a Dodge Hellfire 807 horsepower, chassis, and then they skinned it to look like the older car.
Yeah.
So that was one of their approaches. And again, I'm just saying, these are things people could be looking into.
It says that this has a dry weight of 3,434 pounds. Well, that's actually heavier than a standard Corvette Stingray by 68 pounds. Everybody knows that.
Okay, and I have another anecdote for you here in a second. You won't believe it.
You'll notice that it's a little wider. So if that's what it weighs dry, what does it weigh after a good rain?
Oh, Robert. You mean like the car wash would slow down
Yeah,
your mind?
right, yeah.
You're not supposed to worry about that if you have this Corvette.
Oh, okay,
Don't
all right.
worry about that. Now, my little anecdote that I will give to you, because I almost forgot to mention this.
Oh, please.
We're talking about this very interesting, the interesting research that led to carbon nanofibers being vapor deposited from coal.
Bye-bye.
It actually kind of emerged from part of the Star Wars research. People were looking for materials, composites for space, and yada yada. Well, the interesting thing was, when I talked to the company that is presently doing that, Pyrograph 3, we'll probably put that up sometime and we'll talk about it. And the gentleman I was talking to, Elliot Kennel, who used to work for Zonlo and Al Stiller at WVU, and he now works for this company. He said the original funding and impetus for taking that kind of Star Wars concept of vapor deposition of fibers, and at that time they didn't even really know what size they were. He said, we just knew, he says, we know now that they are nanoscale fibers, which is really an amazing thing. At that time, he said, we just knew they were really small fibers. The funding was from General Motors because they were looking at using it to make the Corvette Stingray.
And that was back in the 80s.
Yeah, back in the
1980s.
80s. Yeah, it was back in the 80s. So
it's a shame that didn't go a little further.
Well,
I wonder who stopped that from happening.
Part of it, again, we always have to look at things are cost. Some things are cost, but still.
But at the same time, if you're saving gas over the long run.
Now, and here's where I have to explain to you about cost. If it turns out, Robert, that your product means that I sell less gasoline in my station,
then you might be against that and lobby against it.
I might say, why don't you use that for just fishing rods or something? That's what I would say. Okay. All right, we're going to jump.
Things like banjos.
Well, banjos. Now we're in the
No, nobody wants that.
Yeah, General Motors decided not to make banjos.
I guess that's what happened.
Now, you were talking about interesting stuff going on with meteors. I'm going to click on this next topic, but as we do, you are also preparing this evening to be going out to Grandview Park.
I'm so glad that you mentioned
wanted
that,
to mention that, especially
that's
for
one of my
local
little checkpoints here that I wanted to mention. Tonight, we are going to be at Grandview Park.
Love that park.
At the Zipline Adventure area, and Libby and myself and who knows how many fun people will be showing up. We will have our telescopes ready to go. It might be a little cloudy. It might be a lot cloudy. We don't know. We will find out when we get there. My hope is that the clouds will clear up and we'll be able to get to see Saturn for the first time. Saturn and her magnificent ring systems and the second largest moon, I should say planetary moon in the solar system, Titan. We're hoping that we'll I get to see just after sunset the elusive planet Mercury will be just above the horizon, and we know right where to look for that. And then between Mercury setting and it getting dark enough for Saturn to be seen, we'll start looking at some deep sky objects. So we'll be looking for what are called the shallow sky objects.
Wait, did you say deep state objects or
no,
deep sky? Excuse me.
I'm sorry. Yes, deep space objects.
I'm just thinking
or
of
deep
my
sky
nightmare,
objects.
which I have to tell you about
okay. And then we will be looking in between those. we will be looking at what is called the shallow sky objects. Those are things in the solar system, like Saturn, Mercury, Titan, that kind of thing. It should be really fun, and we will be there from 8 p.m. until 10 p.m.
Yeah.
And love to have you. If you've not been to Grandview Park, I highly suggest showing up at or before 8 o'clock so you can watch the sunset with us. That is one of my favorite things to do. And then you get to watch the stars sort of pop out as the sky gets darker.
And that's the only chance really to catch Mercury.
Yes.
Now, and there could be some remnants of the Perseid meteor
There
shower.
might be some Perseid meteor
We're
showers.
at the trailing end of
Yes.
it. It lasts, they consider it to last a longer period.
Yes.
They always talk about the peak being like, I think it was the 11th into the 12th.
Yeah.
But we're still close enough that you could see something. Now, of course, because I was just thinking about my commercial for Grandview Park, I have my zip line sound effect. Did you hear that zip line?
I do. That's a nice rendition.
Well, that's really good.
But
All right.
you forgot the blood-curdling screams.
All right, evidence that that giant meteorite impacts created the continents. Now, I had
Created the continents.
This is like a new thing from researchers who've looked
Curtin University. I have done some research into Curtin University because they do online and distance graduate programs. It says new research has provided the strongest evidence yet that Earth's continents were formed by giant meteorite impacts that were particularly prevalent during the first billion years or so of our planet's 4.5 billion year history.
Yeah. Now, they go on to explain, what they talk about. How did we figure this out? Examining tiny crystals of zircon.
Zircon in the rocks.
Oh, we're in Western Australia where the roads are so narrow.
Yeah, you can't even have a Tesla truck on it.
This is what's so cool, though. In Pilbara Craton in Western Australia, that's considered to be the best preserved remnant of ancient Earth crust. It says they found evidence of these giant meteorite impacts.
That's really fascinating. Well,
So-
that makes perfect sense.
Well, and the thing that they do, they talk about being able to analyze the isotopes, and the kind of methodology here is pretty complex but very interesting, especially if you are into the geology and the almost like forensic geology, I guess, if you look at that. Anyway, but what they're basically looking at is that the kind of perturbation and the impact on the Earth's crust by these meteorites is what led to the actual formation of the land masses. Mineral deposits are the end result of a process known as crustal differentiation, which began with the formation of the earliest land masses.
So they're not talking that the meteorite impacts created the physical continents. They're talking about the material that makes the continents.
Yeah,
All right.
and the way
Sure.
like I said, reading through this, again, like I said, very very technical, but basically, the whole mechanism for why we do have these continents, as they are spread on the Earth and stuff like that, is related to these. And then they have there's a link to the publication Nature where they have the full paper. So
Very neat. Okay, I will have to read through that. That's a really neat idea.
All right, now this next
That's
story.
awesome.
I'll tell you what. I'm just looking at our time, and since we were talking a lot about the kind of possibilities with carbon, I'm going to jump over magnecular, and I'm going to skip the dice for a second, and let's look at the
Graphene fiber. Okay.
Yeah, and I just wanted to make sure I got this in because this is a neat article from the Penn State College of Engineering. Using lab experiments and simulations, a team of researchers found that by adding graphene to their carbon fiber production, they were greatly strengthened the material, and this may pave the way for higher strength, cost-effective car materials. Who have I heard mentioning that before? I think you brought it up earlier. Right?
I think somebody did. So we're looking at. Okay.
Here's what they do. So it says what they're doing is they're adding small amounts of 2D, two-dimensional graphene.
So they're making flakes of graphene, essentially.
That's what I'm thinking,
Right?
which is
Yeah.
almost an analogy to what steel is.
Exactly.
People don't realize that iron.
on a nanoscopic level as opposed to a microscopic level, because, as we all know, steel is
some people know.
Well, yeah.
Okay.
As should be known.
Okay.
Steel is a iron carbon composite.
Yeah, and it's the way it
That's
should
what
be looked
steel
at.
is. It's an iron carbon composite. Years and years ago, I remember some people that I was working with were surprised when I brought that up.
That it was a composite.
That it is a composite. It's an iron carbon composite.
Hello there.
And there are
Do
these
you have any high
giant-
quality magnifying glasses?
there are these giant carbon flakes essentially.
Yeah.
in it.
And you can physically see them.
Yes, exactly. Yeah.
Oh, well.
Wow, that's really nifty.
So the thing that's neat about this is that they go through.
Boy, shop owners don't wear ties much anymore.
Hey,
Hey.
we do.
I do.
This
Look
is
like a scientist.
Thank you.
this is
I
a
am.
science tie.
No, you might have a market for magnifying glasses.
We do,
I
yes.
mean, I have a cheap one that I bought at Rite Aid, but it's plastic.
Yeah, that's all we have right now.
You guys have any of the loops?
I can show you.
And you can
I
show me what you
think
have.
we are out of loops.
If I think
I've been out of the loop myself. Just kidding. No. All right. So the point of this whole article is that that the process. They go back and they talk about the cost and all that. But anyway, by doing this, and the illustrations at the top give you a sense of, you can see where
Yeah.
you're looking at this and going, okay, I see the little graphene flake that's
Yeah.
there. What it does is it kind of adds. I'm thinking it adds as a template for the growth of the other fibers and things
Certainly.
like that. But the part that's
It
important.
also gives a place to entangle those.
Yeah. Well,
those low
it's
carbon
really a great
fibers.
thing, but the reason, besides being much more cost effective, they're saying by just adding this the graphene, two-dimensional graphene as they call, allows the team to create a carbon fiber that is 225% stronger and 184% more stiff, or the modulus,
Wow.
than conventional, made from, when they talk about pan-based, that's, I think
Yeah.
it's a petroleum-based plastic. I think it's polyacrylic nitrile or something like that. That it's a long process where you have to make the plastic first, and then you have to carbonize it, and So this is another one of those not great pieces of news that it's going to be. Right now, carbon fiber is about $15 a pound.
I saw that. I was just about to bring that up, that carbon fiber sells for $15 per pound today. And again, if you look at what that is, that's about, I don't know, 50 times more expensive than coal.
Yeah.
per- per,
There's
like, pound?
no question that
Yeah.
they're deriving it from. Now, like I said, the other thing that's interesting to me. So take a look at this article, and we're going to jump back. One of the things I found interesting was that I know guitar makers, and one of the big things they're talking about is how, if you've ever noticed, like if you're cleaning out your fireplace and there are chunks of charcoal, and
Right.
they go ping. They have all kinds of
Yes.
great properties.
Yes, they do.
So, the idea, as we had with the nanocellulose, that you could have a biosource for your carbon fibers is another really cool thing. Now, let's click on this story that says magnecular, because you're going to look at this and go, well, I don't see anything about magnecular here. This is an article that just came out from phys.org, phys.org, those physics guys. And as I read through this, I have to preface it with the fact that Robert and I have talked in the past about some scientists who have actually talked about the process of they're actually remediating wastes and stuff. Like they've got
Yes.
sewage that maybe somebody dumped acetone in with it, and maybe it has other oil and stuff like that. And what they do is they take as people have tried to do in treating garbage and remediating sewage and stuff like that, they have a big, like a carbon arc and
Yeah.
a huge magnetic vortex that goes on in a carbon arc. They claim, have a good one. They claim it has a property of causing the spin of various components of your typical molecules. Like if you've got
Right.
carbon, you've got hydrogen, you've got oxygen, and it imparts a change in the spin that basically shows up as what they called a mild molecular bonding. If you've ever had two magnets, you go, oh, I'm going to put these two together, and they snap together. But you can pull them apart.
Right.
They're not like permanently glued. So with that in mind, I was looking at this article, and it says, new conclusion is that new research on magnetic phase separation in microgravity.
Microphase
I thought,
separation.
what is this microgravity?
This sounds a lot like the magnecular things that we've
Well,
been
and when I looked at
talking
that,
about in Radio
this-
Science News
I'm
for
going to read
years.
this one little paragraph. Lead
Okay.
author said that on the International Space Station, oxygen is generated using an electrolytic cell that splits water and hydrogen. Right?
Sure.
That's a tough thing. It said that what they figured out that efficient phase separation in reduced gravitational environments is obsolete, and so they're looking for another way. And so, long story short, it says, I'm going to go clear to the end because it talks about. Basically, they were able to use hydrogen production in water can be achieved by, because we're in a situation where the gravity is not an issue and all that kind of stuff. The study demonstrates for the first time gas bubbles can be attracted to and repelled from a simple neodymium magnet in microgravity by immersing it in different types of aqueous solution. So now, of course, I'm
that's
looking at this and I'm
interesting.
going, well, this is a weird little thing, and then you have to ask yourself, well, I understand magnetism and the neodymium magnet, but in order for this to happen,
they would have to be magnetic.
well, and they're just talking about normal stuff that hasn't been like ripped or affected by a vortex of,
So you mean under microgravity conditions that bubbles of O2
and hydrogen.
will either be attracted to or repelled by a neodymium magnet?
Well, and right there within that sentence, you're implying that of a bunch of random molecules, some of them may have a certain spin and others may have another spin.
Right.
Or, even that's...
Isn't that interesting?
So basically, this lends credence to the concept that there is, even just existing in nature,
Right.
without any kind of, trying to
Without
ramp it up,
doing
spinning it up, or
anything
doing,
extra.
that there is this very slight tendency for this to happen, but it takes being in microgravity and in these aqueous solutions for this to happen. But they're looking at this as being a way to literally develop, oxygen generating systems in space, using this concept of, as they say, just a simple neodymium magnet. And having read this, I just thought,
Wow.
this is one of those little clues.
It's almost like somebody just discovered
Magnecular,
magnecular properties on a small scale.
a very small scale. Yeah.
that can only really be seen in a microgravity condition
Yeah.
when
and-
there isn't a giant up or down,
Right.
right? Okay.
So this
wow.
is so this is really cool. Now, I say that it's cool because there are scientists that we have discussed on this show who have said that, oh, I was just trying to purify water and, basically, put all the hydrocarbons and sewage and I put them in a carbon arc and, of course, they got ripped apart by the
and I
huge
got
magnetic
something
vortex.
completely new, essentially.
And basically what they claimed was they were getting, for example, hydrogen instead of you typically think you're
H2s.
you're going to think you have these little H2 molecules.
Yeah.
They were stacking up on each other
H6s,
yeah.
H8s and H10s.
Which is
right.
which is a profound issue if you're thinking of a hydrogen economy, because I'm sure everybody has tattooed on their arm the gas laws, the Avogadro's
I
number,
do.
the idea that a particular gaseous molecule, whether it's hydrogen little or it's like a bigger molecule
Right.
like methane or all these things, you could still get the same amount of molecules in a liter. So the idea is that if instead of H2 you could have H10 and then at the same pressure have 10 times more energy density,
Right.
that's a profound thing.
That is a
And this
profound
little
thing.
article, I'm going to have to, I want to look at it more closely.
Yeah, yeah.
But having read through it and just seeing this,
It would be fascinating to send these guys some of our links to the magnecular things and just see what happens.
Well,
I
it's-
bet
yeah.
they would
well, and it's what you
be
need
very
is,
interested.
It also reflects the idea that these people who are doing something with a really chaotic environment, like if you're putting water and dissolved hydrocarbons and gasoline and sewage,
Yeah.
hydrocarbon material, and then you're just blasting it all apart in a really a carbon arc kind of thing, which has these vortexes of magnetism.
Oh
I
yeah,
mean, it's
there's all
just like,
kinds of wild things happening in there.
you're likely to be spinning some things up. And then,
Yep.
of course, the ones who, as this thing, which I hadn't seen initially that you pointed out, that they're saying that they could be, some were repelled and some were attracted.
Yeah.
That means that you have already said that, within nature, when we've done
You
nothing
will
to it,
you'll get a positive and a negative that will
There are-
attract and could then start to link up.
well, and the idea that there's a variation
Yeah.
within a given set of molecules of their, let's just use the term magnecular bonding
Right.
capability. So it's
This
one of the
is
reasons.
really
And
fascinating.
I don't think these guys are thinking about that at all.
No.
So I think that's
So
what's kind of cool.
hopefully one of them's listening in and going, guys, I think I know what our next grant is.
Well, I know. Should we give them that? Maybe we should pursue that grant, Robert. I don't know.
Yes,
you know
in
anybody in
all
science?
of our spare time. Yeah.
All right. Now, this thing about roll of dice, we talked about this briefly because it said why Romans used lopsided dice. I'm going
Because they were
"Say
cheaters."
what? Say what? There's a nice picture of the map where they found these the Linus Germanicus, modern day Neanderthals, showed location of Roman sites included in this study. So here's the picture. There's the flattened, there's the cubic.
And the elongated.
These were actually game pieces used by ancient denizens of the this particular island. It looks like it's Friesel. Anyway, map of. It told me what it was, but it disappeared. Map of modern day. Oh, this is in the Netherlands, showing
Okay.
Roman sites included in the study. Number of dice measured, each location. There's a picture of the thing. So long story short, during the time of the Roman Empire, people played a game called taberna, which is like backgammon, which involved throwing dice.
Sure.
The dice were made of bone, metal, or clay. They had no carbon composites back
Oh.
then. And the symbols had different numbers, as with modern, but they differed in shape. The Roman dice were usually elongated or made into odd shapes that made them asymmetrical.
Okay. Asymmetrical. Oh.
Yeah,
Sounds like somebody's trying to load some dice there.
Well, it says that to find out if the Romans made their dice as a means of cheating, the researchers conducted experiments. They asked 23 students to place marks on reproductions of the asymmetric. Then they did some studies.
Oh, that's really funny.
It said the researchers reasoned that because the students would not know the purpose of the experiment, they had no incentive to cheat. They would mostly place the marks randomly. But that was not the case. The students still placed the 1 and the 6 on the larger sides. When asked why, they said it was easier because starting on a large side meant ending up on a large side when they were doing the rest of them, because you're going to have 6 things. A finding that suggests that the Romans were not, I put maybe in there, we're not trying to cheat, but we're just trying to make life easier for themselves as they constructed. It also suggests...
Wait. After you make the first set of dice
Yeah.
and you see how it rolls, then you're either going to keep it the same or you're going to change it to satisfy your needs.
Well, here's
Come
the
on,
other thing
guys.
too. They also say it also suggests that they were not too concerned about which face was assigned the number because they believed random events such as dice throwing were governed by the fates. And that was just your fate that you lost. But the researchers also note that the more clever people likely figured out over time, certain dies would be more likely to win.
Yeah,
Ah,
right.
okay. So the
Blame
bottom,
it on the fates.
the fates.
I didn't load these dice.
It was the fates.
It's the fates. It's your fate to be treated by the fates
the fates.
in the fate that you got.
We're probably going to barely get to
Oh,
I'm
that's
going to do the
really
first
funny.
eDNA story
right.
because in DNA, scientists find solution to energy transformative electronics. Now, we didn't get to touch on this much at all because it's kind of a long story, and even as I look now, we're going to probably run out of time to talk about. The basic thing is the structure of DNA means that you can use the DNA molecule to create
Engineer
all kinds
electronics.
of interesting electronics.
Well, of course.
Cryoelectronic EM has emerged as a main technique for in biology for determining atomic structures of proteins. I'm going to have to start the music here in a second. But I probably won't use the banjo just to give people
okay.
some relief. So, anyway, they're using in electronics. What they're starting to look at doing is using DNA as a template to build the things
Sure.
they want to build. And
It makes perfect sense
the big thing
because
is-
that's its job.
It's his job, and it says it validates the
Right.
possibility of building room temperature superconductor based on this particular scientist named Little. So I would ask you to take the time to read this,
I will,
especially
I
if
will,
you are
thank you.
into
This is really nifty.
cool things, DNA, but also superconductor.
And this is from the University of Virginia Health System.
Yeah.
Isn't that interesting?
yeah, it's really
That's
cool.
a neat thing that they're
Superconducting your health.
Says
Anyway,
scientists have used DNA to overcome a nearly insurmountable obstacle to engineer materials that would revolutionize electronics. What a great phrase.
Wow.
Hey, just want to say, we will be at Granby Park tonight from 8 until 10 p.m., August 13th.
sounds great. Be there or be elongated.